Any ill effects from the Van Allen radiation belts?
No, now I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did.
Beginning at an altitude of 1,000 miles and extending an additional 25,000 miles, lay lethal bands of radiation called the Van Allen radiation belts. Every space mission in history with humans on board, from both the United States and Soviet Union, from the first in 1961 to the present, has been well below this deadly radiation field. Mercury, Gemini, Soyuz, Skylab, the Space Shuttle, all maintained altitudes well below 1,000 miles. All except Apollo.
I don't know the distance to the Van Allen radiation belt, and if we did, it wasn't a problem. If we were going to encounter it, then we would have had to build the spacecraft and the spacesuit to not give humans a problem. You don't just build something and hope it works. You study to see what the threats are, the environment is, and then you say, how thick do I have to make the metal on the spacecraft so that going through this kind of radiation or these kind of meteoroids, it won't get hurt. And so then we build it that way.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
No effects on your cells?
Didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation.
So you see, Team Apollo didn't know about this deadly radiation belt that would have killed them, so they weren't affected by it. Another interesting aspect of space travel is that it's not possible because thrust and combustion are not viable in a vacuum. Let's review a couple of experiments in a vacuum chamber that prove what I am talking about. First experiment, thrust in a vacuum.
You see when I turn the fan on, it blows the feather all over the place. This is, of course, at atmospheric pressure right now. So since we're at Martian air pressure, let's unplug the vacuum pump and let's turn on this fan. Now place your bets as to what's going to happen to this feather. Now the fan's only going to produce maybe 10 miles per hour worth of wind. On the surface of Mars, the fastest recorded wind speed is about 70 miles an hour. But let's say the superstorm in the Martian had wind speeds of 200 miles an hour, 20 times what we have here. To compensate for that, I imagine the feather is about 20 times easier to push over than a spaceship. So let's see what happens. Okay, fans on. And the feather's not moving. In fact, let's zoom in on that.
Thrust does not work in a vacuum, and thrust would be needed to traverse outer space. Second experiment, combustion in a vacuum.
This is a mixture of sugar, potassium nitrate, and iron oxide. This is used in amateur rockets because the ingredients are readily available and the amount of thrust it produces is quite high. So let's light this on fire and see how it does. So this is in Earth atmosphere. As you can see, it burns rather rapidly, producing a little bit of thrust even. As you can see towards the end, it moved it around. So now let's try it inside of a vacuum. No ignition. That's interesting.
Combustion does not work in a vacuum. This is a very big deal. Space travel falls on its face and breaks it, then dies with these two vacuum chamber experiments. Thanks, Cody's Lab.